Hey guys, welcome to a new tutorial today on what we were doing. We had already finished using vectors and using scalar functions. We had also seen squashing or collapsing the rows into one. If you see last time what we had done is we had done element-wise operation and we had also done reduction operations. So reduction across different dimensions, and we understood that. Today what we're going to do is we're going to check how we will do the most important activation functions, right? We will go over activation functions again, but this is just to get you some amount of familiarity with activation functions. So let's say I have x is equal to torch.tensor, and we can put a nice big value over here. We can put 1, 3, 5, 0, -3, -1, 0.2. Okay, I mean, this seems to be nice. Okay, now there are three main functions which I want you to go through. One is the sigmoid. Before sigmoid, we have the ReLU, which is rectified linear unit. We'll go over each. If I rectified linear unit, and finally we have the sigmoid, moid, and finally we have the softmax. Softmax is for creating probability distributions such that all of the terms add to 1. And we will see how each of these behave, right? Right now. So we can just write over here, ReLU is equal to, yeah, you can do torch.nn.functional. That is definitely a way. The other way is just to do torch.ReLU. That will also work. Okay. So we will do precisely that. And we won't necessarily use the other methodology. Okay. We will do torch.nn.functional next time. Okay. ReLU x. Okay. Oh, okay. My bad. I have to import torch. Okay. By the way, rectified linear unit, what it does is any value lower to 0 becomes 0. That's what ReLU does. Okay. Any value lower to 0 becomes 0. This is what ReLU. What does sigmoid do? Sigmoid basically squashes the function, just the values to be in between -1 +1, if I'm not wrong. Let's just try it out. Sigmoid, torch.sigmoid, okay? And torch.softmax also. Softmax will give you a probability distribution. Okay, so let's have a look. Okay, first we'll go over sigmoid, okay? So torch.ReLU is working fine. Sigmoid basically quashes the value between -1 to +1. Basically takes, you know what? We should actually just check the sigmoid function. Sigmoid function. And over here, mathematical that produces an S-shaped curve, mapping any real valued input to an output between 0 and 1. Okay, so negative infinity. So this is like the tan H curve. So the negative infinity and positive infinity. So if you're negative infinity, it goes to 0. If you're positive infinity, it goes to 1. And any value in between will be one of these random values, right? This is basically the sigmoid function, which is equal to 1 divided by 1 plus e to the power of minus x, or rather e to the power x divided by e to the power of x plus 1. Very interesting stuff. So at 0, it will be half at 0. So because e to the 0 is 1 divided by 1 plus 1 is 2, so it will be half. It will be 0.5 at 0. And any value at infinity will be 1, and any value at negative infinity will be -1. Sorry, will be 0. My bad, will be 0. So 0, 0.5, and 1. So 0 is negative infinity, basically. Right? Coming back to softmax, what is the error? softmax last dim kernel not implemented for long. So this means that we will have to convert it into float. So for doing that, what we can do is a very, very simple operation. We can just write x is equal to x dot to d type is equal to torch dot float 30. Okay. So I think this should solve it. Yeah, it did solve it. It gave us the value. That's because we just converted the type to float. In fact, you can print x again. It's going to be the same. Print x value is, you will get the same value. So this is exactly x. It just converted into a proper floating point value. And now finally we do softmax. So softmax is basically the value that is used to summate everything. So actually you can actually do this. Print softmax dot sum. So this will give us a value of 1 actually. See, it gives us a value of 1. So 1 to the e to the power minus 2 is 0.01. This is 0.1 plus 0.8. So 0.8 plus 0.1 is 0.9 already. Plus 0.0005, 0.402 and 0.302. So all of them basically just add up and they become the value 1. So these are your basic activation functions that we'll use. We'll figure out why we use activation functions later, but this is the basics of activation functions. Just remember ReLU, Sigmoid, Softmax. 3 different activation functions which are very commonly used. We'll have leaky ReLU, we'll have GeLU, we'll have different types of activation functions in the future. But first we'll focus on the most basics, right?